Welcome back to Spring Into Math 8. I'm Mr. Burns, and today's lesson is about linear and nonlinear functions. What is a linear function, you may ask yourself? Well, a linear function is a function whose graph is a non-vertical line. Also, a linear function can be written in the form we've seen lots of times before, y equals mx plus b, where m is the slope and b is the y-intercept. Something we should definitely know that's a clear indicator is that variables cannot have exponents. If you see an exponent, we can automatically know that that is not a linear function. So here's a little bit more information about nonlinear functions. Equations that do not graph in a straight line. So if the graph is curvy or has some zigzags in it, or if you put a ruler down on your paper and you notice that it's not really a straight line, then we can consider that or classify that as a nonlinear function. Here's an example. Y equals 5x to the 5th power plus 2. Now, we cannot have exponents in this form because that makes it a nonlinear function. Remember, a linear function is always in the form y equals mx plus b. There's never ever going to be an exponent in it. So writing a linear function using a graph. We're using the slope-intercept form, y2 minus y1 over x2 minus x1. And we're using that information to gain access and knowledge to what the slope is going to be in our y equals mx plus b form. Here's a picture of a graph. Now, the graph is graphed in a straight red line. So we don't see any zigzags, we don't see any curves, and from the naked eye, it kind of looks like a straight line. So we have the points highlighted here, -3 and 3, and the points highlighted 3, -1. So let's test that to make sure. So we have those coordinates, -3 and 3, and the coordinate 3, -1. We're inserting that information into that slope formula we've used lots of times this year together. And when I insert that, the top part of my fraction is -1 minus 3, and the bottom part is 3 minus -3. And that results in -4 over 6. And I can reduce that to -2 over 3. So we can say that that slope is -2 over 3. We have a y-intercept of 0, 1. So we can write this equation as y equals -2/3 x plus 1. Now, because there's no exponents, we know it's linear. Because it was a straight line, we know it's linear. If you see a curvy line or an exponent, you should automatically think to yourself, that is a non-linear function. So writing a linear function from a table. Remember, you can make coordinates from a function table. So pick 2. We have x equals -3, -2, -1, and 0 on top, and across the bottom we have 9, 7, 5, and 3 as the y values. So we're going to graph some points to see where it crosses the y-axis. So let's go ahead and look at that. But first we need to go ahead and find out what the slope is going to be. So again, going back to that slope formula, we're inserting some information into it. We pulled from our function table. So I pulled -3, 9, and -2, 7 from the function table to insert into that slope formula. I've solved that slope formula here for you. 7 minus 9 on top, which results in -2. And on the bottom, we have -2 minus -3, which results in +1. And -2 over 1 as a fraction can be simplified to just the whole number -2. Now, we saw in the graph that the y-intercept was 3. So our equation is y equals -2x plus 3. Again, we see it's in that y equals mx plus b format, so we should think to ourselves, yes, this is a linear function. There's no exponents here listed, so we know that that has to be a linear function. If you see an exponent, we have a nonlinear function. So here's a quick little quiz for you here at the end. Linear versus nonlinear. Ask yourself in question 1, y equals 5x raised to the 6th power plus 2. Do you think it's linear or nonlinear? Well, based on what we see here, having an exponent inside that equation, we should think to ourselves that is a non-linear equation because linear equations do not have exponents. Number 2, y equals 2x minus 3 plus 15. Now, I don't see an exponent, and that to me means that we have a linear function. So that's it for today, folks. I hope you had a great time. I'll catch you next time in chapter review.